Hello students, today we are going to factor. Now we've already factored quadratics, so I'd like to start there. Remember, factoring means to write a sum or a difference as a product. I would like you to press pause on your video and I'd like you to factor each of these expressions, and when you're ready, press play and we will check your answers. Here are my solutions. The first problem is just your normal quadratic leading coefficient 1. I need to find two numbers that multiply to 10 but add to 7. Those numbers are 2 and 5. In this problem, we're factoring difference of squares. You've got to remember how that factors. Remember, difference of squares looks like this. The perfect squares with the minus between it. So that factors as a minus b times a plus b. So you will notice that 4x squared is a perfect square, and so is 25. So a is 2x, b is 5, and you follow this formula. In this one, all we could do is factor out a GCF. That GCF is 3x. And now in this one, we're still factoring a quadratic, but this one has a leading coefficient. So to do this one, I've got to multiply my a and my c. That's 2 times 1, or 2. And think of two numbers that multiply to 2, but add to 3. Those numbers were 2 and 1. Then I divide by my leading coefficient and simplify the fraction if I can. 2 over 2 simplifies to 1 over 1. And now I have my coefficients of my factored form from the bottom up. So I have 2x plus 1 times x plus 1. This one was difference of squares, factored just like the one above it. And then finally, this one, I have to factor out a GCF first, and then I notice it's the difference of squares, and it factors like this. Now we want to apply those same ideas to factoring polynomials that have degrees higher than 2. We can factor a lot of them in the same way we did before. You'll notice that this still is the difference of squares, even though this is to the 4th power. So this would factor as x squared minus 4 times x squared plus 4. Now I've got to keep factoring until it's prime, and you can never factor sum of squares, but you can factor difference of squares. So this one factors further as x minus 2, x plus 2, and that is my final factored form. Now, sometimes there's a GCF that is in the form of a variable besides the numbers. So as I look at this problem, I see that my GCF is 2x. When I factor out a 2x, on the inside then, I have a quadratic. And if I can factor that quadratic further, I should. So I need two numbers that multiply to 2 and add to 3. Those numbers are 2 and 1. So x plus 2, x plus 1. And now I have the final factored form. 2x times the quantity x plus 2, and then times the quantity x plus 1. If you stop here, it's not wrong, but it's not done, so you would lose points. You need to factor until all the factors are prime. Now, in this last one, it doesn't quite look like a quadratic, but it is in quadratic form. I'm going to start by making a substitution so you can see what I mean, but over time I want you to get where you don't need to make that substitution. So I'm going to let a equal x squared. And if I do that and substitute back in, x to the 4th would be a squared minus 6a plus 8. Now that factors. It's just a normal quadratic. So I need numbers that multiply to 8 but add to negative 6. And those numbers are 2 and 4, negative 2 and negative 4. So this factors as a minus 2 and a minus 4. But remember, a is not in our original problem, x is. So let's substitute back in the x. So this is x squared minus 2 and x squared minus 4. Now the x squared minus 2 doesn't factor because 2 is not a perfect square, but x squared minus 4 does. Each of these are perfect squares, so I can factor it further. So this is x squared minus 2, x minus 2, x plus 2. Now, I made the substitution so you could see this is in quadratic form, but I want you to get to the point where you don't need to do that. So if I were to look at this expression, I would go, okay, this is in quadratic form. So I know that I'm going to set it up like a normal factoring a quadratic, and my x squareds go here, and then I'm still thinking what multiplies to positive 8 and adds to negative 6. Those numbers were negative 4 and negative 2. Okay, so you can recognize the quadratic form because this power is 2 times that power, and then there's no variable over there. And then again, I would continue factoring. That's x minus 2, x plus 2, and then again, x squared minus 2 doesn't factor. It is the difference, but 2 is not a perfect square. So those are some examples of factoring higher order polynomials with the same set of skills as we were using to factor quadratics. Now there is another case, and that is difference in sum of cubes. Okay, so there's 3 other factoring techniques: difference of 2 cubes, sum of 2 cubes, and factoring by grouping, and that uses the GCF. I'd like to start here though, because it's going to be important that you recognize what a perfect cube is. So we have a much better time remembering the perfect squares, but we do need to see this. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed 216, 7 cubed 343, and 8 cubed 512. Now, to be honest with you, these I tend not to remember so well, but we still can work that out. And I'll talk about that later as we're trying to identify different cases. So remember, anything to a third power is always a perfect cube. So x raised to the third power, perfect cube. Just like any variable raised to a power that is divisible by 3 is a perfect cube. Okay, so this is how sum of cubes factors. This is how difference of cube factors. Just like you memorized how to factor difference of squares, you have to memorize how to factor difference in sum of cubes. So they do look very similar in that I have a perfect cube added to a perfect cube. Here's the difference. Notice how they factor. All the letters here match these. It's only the signs that are different. This plus matches the plus over here. This is the opposite of that one. This is always positive. This one is the same. This one's opposite. This one's always positive. So some students like to remember this using the mnemonic device SOAP. That means same, signs are the same, opposite, this sign and this sign are opposites, this sign and this sign are opposites, and then always positive. This sign is always positive. So however you choose to remember that, it's up to you, but you do need to know it. Now, the key here is that you've got to recognize when you have sum or difference of cubes. Now, notice sum and difference of cubes are 2 terms each. So the only 2 kinds of polynomials that we've seen so far that factor with 2 terms each are the difference of squares, and now the sum of 2 cubes, or the difference of 2 cubes, unless of course it's a GCF. So that's the first step, and you'll notice that all of these cases have exactly 2 terms. Now, as I look at the first one, this is the sum of cubes. If I look at how to factor it, I know that A is equal to X, and B is equal to 3. That's the cube root of 27. So now at this point, all I have to do is plug into my formula here. So this factors as x plus 3, that sign's the same, times a squared, which is x squared, opposite, minus, now a times b, that's 3x, and then the last one, always positive, b squared. So that's how that factors. Now, if you've done this correctly and you pulled out a GCF, if there is one, this trinomial is never going to factor. The next one is difference of cubes. Y cubed is a perfect cube, so is 8. So as I identify what a and b are, a is y and b is 2. So this factors as y minus 2. So a minus b, same. Y squared, that's a squared, plus opposite signs, ab, that's 2y, plus, always positive, b squared. That's how that factors. Now let's look at this one, 3x cubed plus 81. You'll notice 81 is not a perfect cube, and neither is 3x cubed, but there is a GCF, and that GCF is 3. So first I'm going to factor out a GCF. Remember, that's always your first step. So 3 times the quantity x cubed, 81 divided by 3 is 27. Now I have the sum of cubes, where a is x and b is 3. So now I just plug in. So I have 3, and now remember the sign is the same. That should be x plus 3. Then a squared, which is x squared, opposite, that's a minus, a times b, which is 3x, always positive, b squared, 9, and that's how that factors. So remember, always factor out that GCF first. I'd like you to pause your video and do these 3 problems, and when you're ready for the answers, press play again. Here are my answers. You'll notice this was strictly the difference of cubes. 64 is a perfect cube. 4 cubed is 64. Factors like that. And this one, remember, when we have a negative leading coefficient, we factor out the negative. Once I do that, I have the difference of cubes, here. Same thing over here. Factor out a 5x squared. Now I have the sum of cubes, and it factors further. The next thing I'd like to look at is factoring by grouping. You can recognize a factoring by grouping problem when there are 4 or more terms. In general, what we do is we factor pieces of it and we look for a new GCF. So let's look at this example. The first thing I'm going to do is I'm going to look at the first 2 terms and pull out a GCF. The GCF here is x squared, and that factors as x squared times 2x plus 3. Now I'm going to take out the GCF from the second 2 terms. That would be minus 4. That's 2x plus 3. Now if you've done this correctly, what you're going to notice is this part is going to match this part. If they don't match, then you did not do it correctly, because what we're really looking for here is a new GCF. And that new GCF is 2x plus 3. So looking at this, I see 1 term, 2 terms, difference of 2 terms. This is my GCF. I'm going to factor it out. So that becomes 2x plus 3. And then x squared minus 4. Now, if either of these factors further, I have to do that. This does not factor further, but this is the difference of squares, and it does. So that factors as x minus 2, x plus 2. And that is your answer factored completely. Let's try another one. Something I didn't mention is that you should order the terms from greatest to least. I didn't mention that because it already was arranged that way, just like this one is. But if you looked at the powers on these variables and they were mixed up, you would put the highest power first. We're going to follow the same procedure. We're going to look at the first two terms, and we're going to factor out the GCF there, and that's x squared. So I have 2x plus 1. From the next two terms, I'm going to factor out negative 9. Factor out a negative. Negative 9 is 2x then plus 1. Remember what I said, that if you've done this correctly, these pieces have to match perfectly, because the whole goal of grouping is to find a new GCF. So now I can factor out the 2x plus 1, and this becomes x squared minus 9. Now, as in all factoring problems, we always factor until prime. So if any of the factors can factor further, that's something I need to do. And you'll notice that this is the difference of squares, so that factors further. And there's my final factored form. I'd like you to try these next two problems. Press pause on your video, and when you're ready to see the answers, press play again. So here are my answers. From the first two terms, I factor out an x squared. Last two terms, I factored out minus 1. The x plus 3's match. Factors here. This is the difference of squares, and it factors further. Now, just because all of these has factored further up to this point doesn't mean it will always happen that way, but you should always check. In this one, I factored out the GCF for x squared from each of them. In this one, I factored out a negative 1. My groups match, new GCF. This factors further, difference of squares. Now I would like for you to practice some problems all mixed up, all the different methods. Now remember, we can factor quadratic forms. We can factor out a GCF. We can factor sum and difference of cubes. So give these 4 problems a try. Press pause on your video, and when you're ready for the answer, press play again. Here's my answers. The first thing you should do in any factoring problem is factor out a 2x. And when I did that, I was left with a quadratic on the inside. I multiplied the 6 and the negative 3. That was negative 18. I had to think of numbers that multiplied to negative 18 but added to negative 7. That was positive 2 and negative 9. I divided each of these by my leading coefficient, which was 6, and I simplified each fraction. And then I had the coefficients of my factored form. So the 2x stays there. Then I have 3x plus 1, 2x minus 3. Next problem, same idea, factor out a GCF. This is in quadratic form, except now I'm factoring with x to the 4th, x squared. So I need to think of numbers that multiply to negative 8 but add to positive 2. That's 4 and negative 2. And I did not finish that problem. Oh, yes, I did. So looking at this, sum of squares does not factor. X squared minus 2. 2 is not a perfect square. That does not factor further either. So this is the final factored form. And in the third one, I factored out a GCF. But before I did that, I rearranged my terms from highest power to lowest power. Factored out a negative 2x squared. If the leading coefficient's negative, I always factor out that negative. Then I have a quadratic to factors like that. And then finally, in the last one, GCF factors out first. Then I have sum of cubes, and then I use that pattern to factor the x cubed plus 125. Here are 6 more problems to practice. Press pause on your video. When you're ready for the answers, press play again. Here are my answers. Again, you should recognize problems based on the number of terms. Looking at this, there's 4 terms, and I'm highly suspicious that it's going to be a factoring by grouping problem. And in fact, it is. There's no GCF. So I factor out the x squared from the first 2 terms and the minus 4 from the next. And then I get a new GCF. and then I notice the x squared minus 4 factors further, and then I get there. Over here, there was a GCF. I factored that out first. X squared minus 9 factors further. This was in quadratic form, so I had to think of numbers that multiplied to negative 12 but added to negative 1. That was negative 4 and 3. The x squared minus 4 factored further. This does not factor further. This has 4 terms. Highly suspicious of factoring by grouping. Factor out the first two GCF from the first 2 terms and the last 2 terms. These match. So the x minus 3 factors out. You'll notice this is a difference of squares. I have to factor that further. And one thing I always like to do, and it's going to become important later, is that if factors match, I write them as x minus 3 to whatever power that they're in there. So I have x minus 3 squared and then an x plus 3. That's going to have some significance when we start graphing. If I look at 8x to the 4th minus 27, there's a GCF, and then it becomes difference of cubes. And in the last problem, factor out a GCF, and then I have it in quadratic form. Think of numbers that multiply to 9, but add to negative 10. That's negative 9 and negative 1. This factors further. Actually, both of them factor further and gets me there. So now it's time for you to practice. So work on the problems that I've assigned in Schoology, and have a great day.